Perfect, perfect. All right, thank you so much, everyone. My name is Dhruva Goyal, and I'm with myself, Sitaraman. Both of us are the co-founders of BugBase. BugBase is India's largest bug bounty platform, and we really appreciate the opportunity to come here and present. So today I'll be talking about something very interesting and something that we've been working on for a while, which is pen testing using AI. And a little tool that we released about 6 months back called Pentest Copilot. So the goal with today's presentation would actually be going through that tool end to end and actually showing you how it works from a ground up. All right, thank you so much. So a quick introduction about ourselves. My name is Dhruva Sitaraman, as I mentioned earlier. I have been working in the cybersecurity space for a very long while now. Did my OSCP in 10th grade, started with hacking, you know, your usual games as a kid, started getting into more professional security, and started BugBase, was doing bug bounty my whole life. Sitaraman, my friend, I met him in college. He is very interested in the AI and cybersecurity spaces combining, and he has also a lot of experience with full stack development. So naturally, when we came together in college, BugBase was formed, and of course, it is the community that it is today. And I really appreciate that many of our community members are also in the audience today. Beyond that, Aditya and Bhavarth were also a part of our team and really contributed in building this product out. So how I'll actually go through this presentation will be as follows. First, I'll talk a bit about why a product like this is even required. Why isn't everybody over here doing a great job in the cybersecurity space? Why is AI needed in the play? Then we'll talk about how we actually evaluate these models on pen testing tasks, how we actually built out an application that is able to use these to actually conduct penetration testing, talk about how we integrate into some of the workflows that ethical hackers use in a normal basis, and then followed by a quick live demo which Sitaraman will show. So coming to the motivation, right? Why is something like this even required? Now, all of us have used ChatGPT, right? All of us have used GitHub Copilot, hopefully. Initially, I think everybody thought that a lot of these tools would be very gimmicky of sorts, right? You'll use them once, they're a very funny party trick, and then tomorrow you won't be using them again. But very, very interestingly, what ended up happening was when people use them, they realized they have such a strong value in their life that it had an instant product market fit of sorts. So we feel that these tools really increase the productivity of anybody doing anything by 10x, which is the best improvement possible. And us, naturally being curious security engineers, we felt that if we can customize this for a particular niche, which is cybersecurity, there are some amazing results that can be achieved. So what we just started doing was started using ChatGPT in our internal pen test engagements that keep on happening. And what we noted was that ChatGPT is a very smart teacher and as a security engineer. And it's able to describe topics in immense detail and is able to give a lot of examples with it as well. So we said that if it can act as a teacher, it's very possible that we can configure it in a way so that it can act as a pen tester as well, which is what we went about doing. Now, this is a meme that I saw online. I think many of you may have seen as well. How AI is being used in the industry. It was basically, one person wrote an email through ChatGPT to send to his colleague, just made it longer to sound more important. And then the colleague actually ran it through ChatGPT again to make it shorter so that they can quickly understand it. Which shows you, this is not a bad thing, but shows you the kind of, simple things that people have been doing with ChatGPT to show you that there is a lot more to be discovered. Now, in the AI for cybersecurity space, if you look at the current products, this is showing up. Awesome. So most AI-based products are either, of course, tackling very simple use cases or are behind some of the vendor paywalls that are there in place. So some examples include the EDR and XDR solutions that have been using AI for a while now. Phishing detection tools have been using AI. One very interesting thing that I've seen pop up is something called a CISO assistant. Many companies would call it different names. But all in all, it is helping a CISO navigate a complex attack surface dashboard. Another one that I've seen very interestingly personally is writing bug bounty reports. So in our platform, in the past 6 months, somehow all the reports that have been coming are extremely long with very eloquent English. And naturally you can imagine how. And again, this is not something I'm saying this is a bad thing. I think it's very good. But I still feel that there is a lot of opportunity available in the AI space to actually have deeper integrations to get even better outcomes. So I would like to introduce a new concept, which I have termed LLM augmented pen testing. Now, what is LLM augmented pen testing? LLM augmented pen testing is a future where I see AI being a second hand to anybody who's working in the cybersecurity space. All the mundane tasks, in fact, every single person who's working here in the cybersecurity space is facing one massive, massive problem, which is that you have to continuously unlearn and relearn stuff every day. Like keeping up to date with new technologies, keeping up to date with new tools, and so on. The list is unending. We feel that with the use of AI, this can actually be limited, and you can focus on the more creative side of things, directing the process of a pen test, rather than unlearning, relearning, doing all these kinds of things. So we feel it can help in, of course, understanding that context to give directed results, help planning in an engagement, avoid rabbit holes, decide whether to go for A first or B, reduce time in mundane tasks, reading documentation, unlearning and relearning tools, as mentioned earlier, or some people like to say, doom scrolling Twitter. And of course, eventually the goal with this tool would be to act as a standalone junior penetration tester. So I'll give it up to Sitaraman now to actually walk you through how we achieved this. Sitaraman.
Thank you, Dhruv. Am I audible? All right. So Dhruv introduced you to the Copilot, how exactly, what's our vision and what we saw was in the market that can actually work in the pen test world. Now let's go deep into tech and see how we evaluated models, what was the process we followed for Copilot, and the flow of exactly how Copilot conducts a pen test. So here's an image I got from online searching Google, and you can see that an iPhone is fairly torn up, and basically people are just trying to access hidden things out of this iPhone to get access. Right. Now, the thing is, same with GPT. As most of us have used GPT, GPT is very good at doing general purpose tasks. Right. It's not exactly a good pen tester on its own, and it's not specialized in pen test related tasks. So what we had to do was to jailbreak GPT, because due to security concerns, OpenAI has basically added some guardrails which it prohibits GPT to give us commands that actually do malicious things. So what we did was we placed it as a pen testing agent collaborating with a security researcher. So this allowed us to bypass a few guardrails that included retrieving scripts that potentially lead to an RC, editing available exploits based on context, post-exploitation enumeration techniques, and lateral movement techniques, etc. So you can see that we're able to now generate pen test related commands, or get information on how to proceed with a pen test. So moving forward, now how did we evaluate models on penetration testing tasks? So we evaluated multiple models like open source models like Llama, Mistral, and closed source models like GPT. And we created a test benching framework which included multiple test cases from information gathering, reconnaissance, enumeration, exploitation, and many more. So there were almost 200 plus custom scenarios that we created for testing out Copilot. And evaluating the model had to be done by keeping the following criteria. The first one obviously being accuracy. How correct is the command that Copilot is giving, and if it's actually relevant to the current process. Then the response structure, if it's actually structured properly, that we can actually programmatically convert whatever the response the model has given us. And response time, the inference time, how fast is the model giving us the response. And we did a scoring out of 10, right, for each criteria. And we came up with this graph, as now show up on the screen. I'll just get aside. You can see that pre-trained models, like out of the box, which was Mistral 7B, had a score of 0, which obviously Mistral is a general purpose, model which is not actually directed towards pen test tasks. Whereas, as you can see, GPT-4 Turbo, along with the jailbreaking that we did and all the prompts that we added, it performed very well. And also, it was almost perfect in the response structure criteria since OpenAI introduced the JSON mode, right? So we were always getting a JSON response every time. And hence, we basically kept GPT-4 Turbo as our base for Copilot. Now coming up to prompts and LLMs, which is basically the main crux of any LLM application, or which uses the power of LLM. And for all models, like engineering prompts, it's the most important step. We figured out that there are 3 fields that define a prompt, which is target information and knowledge base. You need to know about the target to penetrate and test it, right? And the context of previous tools and the outputs of previous tools let us know what we can do next, and the next potential steps that we actually found out from the outputs for further discovery and exploitation. With these, we can finalize a prompt to get the required tools or plugins. And all these 3 fields totally got us to up to 4,000 tokens, which is actually on the higher side, as 4,000 tokens is quite a lot. And now we come to step chaining, which essentially decreases the number of tokens that we send for each inference. And passing this information to a single prompt is a big issue. And now what we do is in a single pentest loop, what we do is we split it into 4 parts. In the first part, it's target details from the user. Let's say if I'm using Copilot, I'll just type in, I want to hack this IP, or I want to test this IP. Then in the second process, this data is fed, and a command generation prompt is created, in which a command is actually generated. And this command is run through Copilot programmatically, through plugins, which I'll talk about later. This output is then sent to the next step, which is output parsing and summarization. Here, the Copilot summarizes the whole pentest task, what has happened right now, and what do we infer from the current outputs. Once we have that, it generates next steps and creates a to-do list. So we're all security researchers. We like to maintain checklists. So to-do list is the same thing. Copilot maintains the whole context of a pentest engagement, what has happened earlier and what will happen next. So splitting these, a single pentest loop into 4 different GPT inference calls yielded better results. And since having less tokens means a better contextual understanding from the model side, and now the context size has approximately reduced to 2K tokens, and the context was maintained pretty well. Now coming into deep integrations into ethical hacking workflows. So now we learned basically what's happening in the background and what the LLM is actually doing. Now what we'll see is how we've integrated all these things into ethical hacking workflows. Now pen testing involves interaction with the real world environments. And we basically created a feature which basically would ask the LLM to return us a format that can be used to call any function, execute code, or run a process. This was possible through the command generation prompt, as we saw earlier. And this will basically give us an output in JSON mentioning, yeah, I want to run bash, I want to run this command, and Copilot is now able to execute that thing. So here are the list of plugins that we have. So during an engagement, a researcher might want to browse Google and understand about a particular exploit or a particular service that was found. So we have the browser plugin for that. We have the run bash plugin, which basically executes command line commands and returns the output. The start listener plugin is used for opening a listener for a reverse shell in the exploitation phase. And to actually create an exploit payload, we have the MSF Venom payload plugin as well, and a generic response plugin. For example, in a current pen testing scenario, the model wants to get additional information from the user. So it will basically return the data in a generic response plugin. Now coming next is retrieval augmented generation, which is RAG. And this is integrating RAG into Copilot resulted in drastic changes. And these were very positive changes, since now we don't have to fine-tune a model whenever a new cybersecurity methodology has been invented or found out. And every time a new CVE comes, we don't need to actually fine-tune a model. We can basically keep a vector database which has all the, which is updated with the new CVEs, the new methodologies of attacks, and stored in embeddings. So embeddings is basically the language of models on how they communicate. Basically, LLMs can understand embeddings, and these embeddings are the things that we're storing in a database. So what happens in Copilot is that the Pentest Copilot has a overall context, and this context is converted into a query that can be actually searched in the vector database into embeddings, basically. And these embeddings are now done. There's a similarity search that goes on in the vector DB querying process, and this results into the relevant details that we want. For example, there's a new CV in recent times, and this is added into the vector database, and then this is queried, and we get the results back. And these results are now then processed by the LLM to fit into the plugin structure. So it works in 3 ways: query processing, information retrieval, and data integration. Now coming to the preferred tooling context. Basically, as a security researcher, you have preference to some tools. Now, for the model to know what is your preference, for example, I like to run Nmap for port scans, right? Now, how will the model know about it? So what we did was we taken all the custom preferred tools, right, and customized the model accordingly by dynamically integrating these list of tools into the system prompt. Now, what happens is that whenever a pen testing scenario is created, let's say I found an IP, now whenever the model will want to add a reconnaissance task, it will always return an nmap command, since that is what is defined in the system prompt. And that is how we took care of preferred tooling for users. And these are a few tools that we've integrated into Copilot, and these are based on the maximum GitHub stars on GitHub, and per use case on what's relevant for researchers and what the researchers generally use. Coming next with final analysis with Copilot. So basically, when you're conducting a pen test engagement, you might come across unknown files, right? There might be some random files that you get while performing a pen test engagement. And to understand what exactly these files do, either I can actually run a few tools and get to know it. Now, the thing is that these files are in binary. How will LLMs actually understand this, right? Binary data cannot be basically understood by LLMs. So what we have done is that we've identified all the files and took out the major components of each file. For example, in ELF files, there are security bits set. There are functions and symbols, type and DLLs, etc. So what we do is we extract these things from the binary so that it can come into a string format, and this string format is well understood by LLMs, and it can summarize that. So this way, Copilot basically is able to analyze files and return it to the user. So the user just uploads the file, and the LLM is able to summarize what is the contents. So these are the few file format that we currently have integrated. Coming next to deployment, I think Dhruv will be able to explain it well and explain how exactly deployment works with Pentest Copilot.
All right. Am I still audible? Yeah. Thanks, Sitaraman. I think that gave a brief idea around how exactly Pentest Copilot is working on a backend. Now, deployment is something that was very interesting for us because we thought, OK, where would a security engineer use this kind of a product? Should it be in a command line? Should it be an extension? Or should it be maybe something on the browser? And browser is something that seemed fairly logical to us because we could potentially set up a testing environment over there as well, which is what we ended up kind of doing and split the Copilot service into 2 parts. One is the actual Copilot service where we thought that all of this orchestration and all of this controlling can actually occur. And the other instance, which is something like a sandbox, wherein all the untrusted code that the Copilot generates or the user may want to input actually runs as well. Now, when a tool like this would be deployed on-prem, that can be the same because we're working on your own infrastructure. But while this is working on a cloud infrastructure, this was very important to us. Secondly, a couple of problems that we thought about that would naturally happen is that, OK, what if one person actually runs this tool against something that they're not authorized to, which could be extremely bad. So at least on our SaaS deployed instances, what we were able to do is completely eliminate egress traffic to the internet. and actually require the user to have a VPN connection in place to actually access the endpoints that they want to test, which prevents, of course, the liability from coming to us. But eventually, we're building out a framework as well, which can sit right on top of Copilot and really disallow any malicious behavior of that sorts. Next is, of course, the security of Pentest Copilot itself, right? What's the point of having a hacking tool if it gets hacked on its own? So this was also something very important to us. And we did a level of rigorous pen testing against the tool and still have a live and active bug bounty program running against it today. And we do hope that everybody does contribute to it and give it a shot. Another thing that I want to address is a bit about deploying AI for offensive security. I think that's the biggest question that I'm really addressing here today, right? Is your job safe? Will you wake up tomorrow and all your security jobs are taken over by AI? I feel that at least for the next couple of months it's not. But and I say that because the pace at which AI is moving is extremely fast. We are not seeing developments happen in the AI space on year. We are seeing them happen per week, per day. In fact, very interestingly, yesterday or day before yesterday, I think the GPT-4o model was released, which we benchmarked, and it is already showing better results than the current model that we're using. So we would push everyone to actually give more creative jobs a try, actually work into application of different techniques in different contexts on applications rather than, of course, general mundane cybersecurity work. The next concern is, of course, ethics around actually deploying an AI for offensive security. Does it sound like Skynet? Yes, it does. So this is also a big concern of ours, like deploying something like this, really controlling what it actually does. So as I mentioned earlier, we're building on a framework to prevent this behavior as well. And finally is the exact reverse, the safety of the AI systems that are being used to date. I think there's a lot of good work happening in this space. In fact, I think it has gotten a lot more attention than security for AI. Interestingly, some of the villages over here also had some good prompt injection challenges, which I gave a shot. So I feel there are a lot of colleagues of mine in India, abroad, all over, who are working in this space and are putting in a lot of effort, and I see good outcomes hoping to come out very, very soon. Now, with regards to future plans, I feel that there is a lot of work left to be done for us. The first is that we need to have a focus on identification of more business logic and unique exploits, rather than exploiting your unique, your generic vulnerabilities that anybody and everybody is able to find. The next thing that I feel is very important to be worked on is fine-tuning our own models. Now, OpenAI is great, but it's not open source yet. And I think Microsoft does have a level of influence over there from what I've heard. So if that does become open source, that's amazing. But regardless, I think every single security researcher would love the independence of having the ability to deploy a model locally on their own that would perform even better than existing models. So this is a lot of the work that we're trying to work on right now as well. The next thing is evasion of WAF and AV. Copilot is very good at identifying exploits, suggesting commands, and telling what to do next. But it assumes that there is no AV present. It assumes that there is no WAF present. And when that exploit actually fails, it shuts down. So having a basis of the presence of a WAF in an engagement is extremely important, and we hope to include that in the tool in the future as well. And one more interesting thing that I did think would be very valuable would be moving more towards red teaming and integrating some of the popular command and control servers like Cobalt Strike or Sliver, so that these C2 servers themselves are so powerful. If we deploy an agent that's able to actually orchestrate them in a powerful way, we can, of course, get a lot out of it. So to wrap this up, Sitaraman will show a quick demo of how Copilot works, and we'll target a simple try hack me box for everyone's reference. Sitaraman, you want to go ahead?
Yeah. Oh, fine. So this is basically the Pentest Copilot dashboard, and here I've spun up a basic workspace. A workspace is basically where you actually do engagement on a particular target, and this is connected to a VPN, right, which can access the vulnerable machine that is there, and we have a command line interface as well, where you can execute commands. Now, what I've done is I've taken a target IP from the root me box on tryhackme. And what I essentially did is copy the target IP address and pasted it on the initial prompt. And as you can see, it has returned me nmap as a command, and it ran the service scan, basically. And I clicked on yes, run the command automatically, and it gave me the output and passed the output into the Copilot dashboard. And now I click continue to summarize this step. As you remember, there are 4 steps to the pentest loop working. So after command generation, we're summarizing the context, and it summarizes the context pretty fast and is able to identify the major things that we actually want to know about. It identified 2 open ports, 22 and 80, running OpenSSH and HTTP service on Apache HTTP. And using this context, we're able to solve the first 3 questions on try hack me, root me box. And basically, what's happening in the background is the pentest loop that we talked about. Firstly, it took the initial prompt, and then it generated a command. Now, after generation of that command, we're able to parse the output of that command and then summarize it. So as you can see, we basically cleared the first 3 questions pretty easily. And here's the analyze file functionality, and you can also give additional context for what is to be done next. Then once I click continue, it updates the to-do list, which is the 4th step. And Pentest Copilot, by default, maintains a checklist so that you don't have to. And it basically recon is pending. And once it's updated, it's done updating. You can click on the continue next loop. And when I open the checklist, it's updated. Now, enumeration is in progress. Reconnaissance is done. And it has also suggested web application analysis, etc. And Copilot is now thinking what to do next. Let's see what it basically gives us. And it gave us a directory busting command, which is Ferox Buster. And this is my preference, by the way. I love to use Ferox Buster instead of Durbuster or something. So it knew that context as well and suggested me Ferox Buster. And I would ask it to run the command, and it actually executed a command on the terminal itself. So Ferox Buster should be running right now. And yeah, it's running right there. And once it will complete the whole execution of Ferox Buster, it will parse that output, and again, this whole loop will start again. And we have also a GUI function there, and yeah, it found out panels and uploads directory. Basically, in RootMe, it's a PHP reverse shell upload, and we're able to upload a malicious PHP file. And so this is it for the demo. What will happen next is that we'll basically generate a payload using Pentest Copilot itself, and then upload it to that malicious endpoint. You can take it ahead, Dhruv.
All right, so that's a wrap for us, everyone. Thank you so much for giving us the opportunity to tell you a bit about what we're doing with Copilot. I would really look forward to everybody participating in the development of this tool. It is entirely free to use, and we would really like to set a base on how the work on LLM augmented pen testing will be happening in the future. And this is like a link wherein you can use to just connect with us and maybe take this ahead. And we'll also look forward to the questions that will be coming up at the villages. Thank you so much. Pleasure.
Thank you, guys.